That's what's happening.
Looks like
Per second, so like 1 to 2.
See,
From, so
It's walking pretty
from
fast.
right here at the start of that,
5 feet per second is no problem.
yeah, like that's definitely 5 feet.
Yeah, but per second.
And so it's so it's a brisk walk.
Yeah, that's
1,000.
That's
you
no
know.
big deal. Yeah,
Doing
that's,
that.
that's easily doable.
That's great.
Okay,
Great.
so let's go
Yeah.
through, the process, right?
Snapshot.
This is a process. Snapshots, good.
Yeah.
Step one. Okay, so here's, they even give us a picture, right? I would much rather just have a, let's do this at
Diagram.
least. Yeah, I would.
Yeah.
I'd much rather just have it. But here, we'll just do this. So that's gonna be X,
Wait, why?
that's Y. Okay. And what do we got here? Those are our variables.
Yeah.
What are our snapshot values?
6
6
feet tall.
Well, that's not
That
snapshot
doesn't
value,
matter.
but like it's still something that we could add to the graph.
Mm-hmm.
R dot 5 feet per second.
Yeah, or not
Yeah.
5. What? Yeah.
Wouldn't
Rate
it-
of
wouldn't
5
it
feet
be-
per second.
X dot.
X dot.
X dot, sorry.
Yeah, because X will
Oh,
call
yeah,
that variable.
okay.
Good, so we know X dot equals
5,
positive 5, negative 5, what is it?
negative 5.
Positive.
Positive.
Oh,
Positive,
positive,
because
because
he's
he's
going
going that way.
farther
I thought he was
Okay,
Fabio.
no.
What?
Oh.
Oh, cause that's, wait, what?
So what are you calling X, I get? Well, maybe yes, that's fine. But what are you gonna call, so you're gonna call, I guess that's fine, if you define, so you're gonna define this quantity right here as X. Okay, that's fine. You can do that. So X dot equals 5.
And then X would be 10.
And X is 10, good. Okay, that's fine.
Y is 15.
Y is 16, is that gonna change? No,
It's
so we could write that in. That doesn't show up very well.
It's
does it?
15.
Oops.
It's, I think 15.
So what's the color that's gonna show up there?
Purple.
Red.
It's 15 too.
So that's 16,
Yeah, it's 15.
15.
15,
In the
sorry.
story, yeah. So I would have about diagram.
Actually, no, it's.
No, it's in the
Oh,
story.
wait,
it says
what is
15.
happening?
They have it
Ah!
And then what's this distance?
6.
That's given to us. So those are numbers on our picture, right? Because they're constant. So what's the other variable here?
What is the rate of the shot?
Okay, so shadow length, that's fine.
Yeah, hypotenuse.
So, would we need different variable for the 10? Because if the whole line is, I don't know, I can't English.
Well, we could call that S. S is bad 'cause it looks like a 5 to me. I wouldn't pick it, but that's, how about if we call it D?
For distance.
Yeah.
So you want.
I was gonna call it R. D, I don't like D's
The
either, 'cause then you
distance.
get D,
D
D.
dot,
Like cake.
So R. So what do we know here? We're looking for what?
R dot, for A.
Yeah, we're just looking for part A, we're looking for R dot, isn't it?
Yeah.
Actually, that's part B.
No. Yeah,
Part B,
that's
right? Okay, so for part B, we're looking for R dot, right? Okay. Let's do part B first. Okay, what's gonna be our,
Proportional.
yeah, okay, so our parent equation is just gonna be a proportion, isn't it? Right? We've got similar triangles here, right? I've got the big triangle and I've got the little triangle. They're similar. So what's one way I could set up a proportion here then?
X plus R over 15 equals 6 over R.
There you go.
Okay,
Or
so-
R over 6.
So X plus R over
15.
15 equals
R over 6.
R over 6.
R over 6, very good. Okay. Okay, make sense?
Third bullet point.
There we go. And what could we do to this to maybe simplify even that parent equation a little bit?
Cross.
Let's cross multiply, good. So if we cross multiply, we're gonna get, what am I gonna get here when I do?
6 plus 6 R.
It's 15 R.
Okay. Or in other words,
Yes.
0 equals 9 R. Oh. That too.
I mean, it's not simpler.
Everybody agree?
Yeah.
So there's our parent equation. Now what?
R dot, derivative.
Yeah. Okay, so now we're just going to relate the rates, right? So 2x dot equals
3R dot.
3r dot, good. And we're just looking for r dot, right? Does x even matter in this?
No.
Not really, does it?
X
That's
dot
kind of weird.
So it's
Okay.
just
So it's
10/3.
Yep, 2/3.
So we end up with, what are we looking for, r dot?
Yeah, so 2/3.
R dot equals 2/3 x dot, which is 2/3 times 5,
so it's
which
10/3.
is 10/3, feet per second, right? In standard units, whatever our units are.
10.
Okay. So there's our step. We just kind of lumped it in there, but there's step 4. We just plugged and chugged, right? Okay, have fun.
Do you get to have their lunch?
no, you have to bring your own.
Seriously?
Jack's been gone for lunch and they leave before they eat, I think. I don't know.
Oh, that sucks.
Lunch just stayed until they eat.
Yeah, they like decent. It depends.
Okay, so there's part B. Now, what about part A? What are we gonna do about part A?
So you're looking for
Wouldn't it
change the
just be
hypotenuse, right?
The entire, if we changed what X is,
Okay, so yeah, so really, we're looking for that whole distance then, right?
yeah, that whole distance stuff.
Let's call that whole thing, I don't know, like C? Who knows?
We call it D dot.
So if we do, let me new color here. Let's see, I really
Oh.
need that guy. That one's kind of missed. We're gonna go with that one. There we go.
Go Bucks.
Yes. Okay, so then this whole thing right here, from there all the way out to there, we're gonna call it Z. Oops,
Just to the tip.
Yep,
Just
you're right. Just from there, there, Z, okay? So how is Z related to X and R?
Z is
Equals X plus R.
Okay, so on this one, we would know that really we could just skip, we've got all this information, right? But really, we're just trying to come up with a parent equation and the way to relate those rates, right? So we know that Z equals X plus R, so what's Z dot equal to?
X dot plus R dot. Dude.
Wow.
Score.
How about that? So we just get what then? 5 plus 10/3, whatever the heck that
Wait,
is.
so why do they have it A and then B like that? Is that,
Because they hate us.
so would that make it more difficult?
Okay, but we could have done this also. We could have said, let's define X as that whole thing and let's call this R.
They could
right?
have done
See what I'm
that.
saying?
Yeah.
That would have been fine too.
You
So-
made that seem really easy, Jordan.
I feel like
That
it's
one
easy
wasn't
now.
that bad.
Yeah.
That one-
Yeah.
I didn't think that was that
Not
bad.
such a big deal.
Which one was the funky one on the test?
The Hales, no,
Oh,
The
that
hill
one
one's
was
kinda
okay.
the Hale, there was one with, not the ball, not the, was it the wrench one?
There
I
was
think it
a,
was one of the- Probably the ball.
the ball dropping I
Yeah,
thought
ball
was,
dropping them sounds stupid.
it was a little harder than this, I think.
Yeah.
Yeah.
But it's real similar. Okay, let's look at another one.
Can you do one that deals with like, the K constant, like constant of
Yeah, can we
proportionality?
just do that one?
Sure.
Oh,
It's right there, 37.
37, okay.
Hey.
Yeah,
Same
so we
thing,
already did
but-
that, but that's all right. We'll look at it again. So, let me grab it. All right, so there it is.
Just your face.
Damn.
Okay, we want to show that the radius of the raindrop decreases at a constant rate. So all we got to do here is, if we're told that
I just
it
forgot.
begins to evaporate at a rate that is proportional to its surface area, right? So what's that mean, right? If it's evaporating, it means the volume is changing, right? So V dot equals negative K times S, which is just 4 pi r squared, right? Where K is some positive constant.
Why is it K? Like, why do they use K?
Because K is always the constant of proportionality.
Because K is constant. Sorry.
If you have a proportionality, remember going back to like algebra 2, you'd write it like that.
No, but
That's direct variation is proportionality.
Oh,
Yeah, K is the constant proportionality. Okay, so there's one thing we can say, right? So then the other thing is we want to show that the radius decreases at a constant rate. Well, okay, so we know that we can start with a parent equation, right? V equals 4/3 pi r cubed, and we can implicitly differentiate to get v dot also. And that's going to just give us 4 pi r squared r dot. So then all we've got to do is just set that equal to that, right? If we do that, what do we get? So we get negative K
equals R dot.
times 4 pi r squared equals 4 pi r squared r dot. So r dot equals negative K. Proved.
I just forgot where the negative K came in.
Yeah.
I completely forgot the coefficient.
And it's negative because it's losing.
Because it's decreasing.
It's decreasing.
Right.
Yeah, that makes sense.
So now we just showed that the radius of the raindrop decreases at a constant rate. R dot equals negative K, where K is just some positive constant. So negative K is negative, right?
Would we have to define as K? Would we have to define K as being larger than 0? Like, or would you?
I would because then you know that. Then it makes sense that it's decreasing. That to me, that's how I would do it.
Okay.
I mean, you could just call it K and make K less than 0, I guess. Same thing. Okay, questions on that?
So the statement, the negative K equals the rate
Equals R dot.
equals R dot. Okay,
Is the proof.
that's your answer.
Well, and then your answer would be probably to say, to take a sentence or two and just discuss that.
Okay, so if this was on the test, like, we do all that, but then we'd have to, like, write out, like.
I would just say, yeah, okay, because K is constant and R dot equals negative K, that shows that radius is decreasing at a constant rate.
We would have to enumerate that.
I would.
Is this a different test from the one we took last time, or is it the same test?
No, it's different.
Like,
It's
how
different numbers though, right?
No, it's different. I
Like,
wouldn't do that.
completely different, like, problems.
The raindrops.
Different
aren't
problems.
anymore.
What happens if the raindrop flies up?
We won't have to, well, we have to know the one that's like 39, the electricity one.
Let's do that one.
Oh.
Okay.
You're giving them ideas.
Yeah, I like that one. That's a good. One.
Gosh.
Because it looks, I don't know.
Looks different.
Yes.
Don't we need all the bottom stuff?
I'd say it's easier. Yeah.
It already gives you the proportion.
Yeah, it gives you the
It already
parent
gives you
equation.
the parent
I'd say it's
equation. Not
easier.
bad,
So
actually.
It just looks like a lot.
Or it just gives us more information than we're used to, so we're scared of it.
okay, so yeah, I mean, really, what are you trying to find here?
R dot.
What radius are changing?
Yeah.
It's R dot.
Okay, right. So, so this is really not a horrible deal, is it? That's our parent equation. So what are we gonna do?
Differentiate.
Yeah, right? So we got some choices here. Let's just think about, I've done this problem, but let's just think about this. When we differentiate this right now, I'm gonna end up getting R's and R dots on the left side, R1s, R1 dots, R2s, R2 dots on the right side. Okay, does that make sense? Is there a way that we could maybe make this a little bit simpler? And that would be fine, right? If we just took this as it is, we could rewrite this as R to the -1 equals R sub 1 to the -1 plus R sub 2 to the -1, right? And I am skipping, let's not skip things. They give us some information here, don't they? So step 1, what's our snapshot stuff? In terms of
capital R dot, is a question.
Right.
R1 is 50, R2 is 75.
R1 dot is 1 and R2 dot is 1.5.
Oh, yeah.
So big.
Right.
I'm just glad that there are all R's.
So
What's an ohm?
an ohm is it's a unit of resistance in physics. So we could do this, right? And it'd be fine. I would probably think about doing this a little differently myself. I would rather not get R's and R dots in there. So how could I accomplish that?
Can you substitute R1 or R2?
Can you just make R1 and R2 like X and Y?
But you can find R1 and R2.
Well, here's what I'm saying. So if this becomes our parent equation, this is a good problem. This is a good source of some discussion here. And this is the kind of stuff that I think makes you good at calculus, is finding ways to make stuff a little
Interruption.
simpler.
At this time, we need all a cappella choir students released to the choir room. And all a cappella students need to be in the choir room at this time.
Okay, so if we start here and we differentiate implicitly, what are we going to get on the left side?
Loop R to the
Negative R.
negative seven.
Times R
Negative.
Times
R dot.
equals,
Negative R1.
1 R.
Negative second. R1 plus something or minus.
right? Okay. And so that's going to give us kind of a mess, right? So that's, if I rewrite this in fractional form, I could multiply everything through by -1, make them all positive, right? And then I'm going to get R dot over R squared equals R1 dot over R1 squared plus R2 dot over R2 squared. I know everything on the right side. On the left side, I've got this R squared. If I multiply both sides by R squared, I mean, really, I've just got that, right? That's gonna allow me to solve for it. It works, doesn't it? And we could finish that. Okay, what if, though? What if we do this? Let's take this original equation. So there it is. And let's simplify the right side. Let's add those fractions up. So I'm going to get, on the right side, I'm going to get R2 plus R1 over R1, R2. Everybody agree if I get common denominator? Everybody see that? Okay, so now, and that's all equal to 1 over R. Okay, I'm going to invert both of these, because I can do that. It's an equation. So I'm going to get R equals the reciprocal. So I'm going to get R1, R2 over R2 plus R1. Okay, if I differentiate both sides, what's that going to give me? So I'm going to get R dot equals a mess. It's a quotient, and I've got a product in the top. It is a mess. But let's just apply the quotient rule here. So I'm going to get bottom, which we know, both of those things, right, they're given to us, times the derivative of the top. Well, what's the derivative of the top?
R1
R1, R2 dot plus R2, R1 dot, right? Minus R1, R2 times the derivative of the bottom, which is R2 dot plus R1 dot, all divided by R2 plus R1 squared. That's, looks pretty bad, but we're just plugging in numbers, right? I don't know if it's worth doing
By
or
that
not.
same logic, if you go to the previous page,
Mhm.
On the previous page, with the negative r to the negative second and all that jumble stuff, we can just plug that into our calculator.
You could, yeah, you could. It's true. You could just say what's R, right? R in terms of, so R is just gonna be the reciprocal of 50 plus the reciprocal of 75 to the negative 1.
Yeah.
So you could do it that way too. It's fine. Just being who I am, I probably would do that, just so I could plug it all in at once on my calculator.
It doesn't seem like that.
But I don't know, I mean, I don't know if it's any harder or easier.
Can you get rid of the R squared plus, R
You can
two
get rid of
plus
one of them?
R one, yeah, can you get rid of that?
You could, okay, so you could do some algebra here on this,
Or you
but
just
I
let
just
your
wouldn't.
calculator do it.
I wouldn't, because you run the risk of making a mistake, and this is gonna end up being a numerical answer anyway. And so at this point, what I would just do is plug everything in. Honestly, what I'd probably do is this. I'd probably say on my calculator,
But no, just like, cause the first term on the top, the R2 plus R1, and then the term on the bottom, you can just take those out really quickly then.
No, you need it to take it from the right side too.
yeah, but you can't, right.
Yeah.
You see. So, but what you could do is you could do something like this. Whenever you're evaluating big ugly expressions like that, I could do this. So I could say, like, let's call this A, B, C, and D, how about? So I could say, what were the values of those, do you remember? Like R1 was,
R1 was 50, R2 was 75, R1 dot was 1, and R2 dot was 1.5.
okay, so you remember them all. Okay, I don't have to go back. Okay, so then, so I could say R1 was 50, you said?
R1 was 50.
50, okay, so we could do 50, store as alpha A. Okay, we could do 75, that's
Yeah,
R2. R 75 store as B. 1 was R1 dot, right?
Yeah.
Okay, so 1 store alpha C. And then 1.5.
Yeah.
Store alpha D.
When you were in your physics degree, did they have these types of calculators? Or did you just do this?
They weren't graphing. They had programmable calculators. Have you ever seen Mr. Cooper's little brown, the one that he uses? That little, it's a
The one-
Texas Instrument, or excuse me, it's an HP 41CB.
It's been a while, but it's like in a brown pack. You
Yeah,
can put it in like a packet.
That was my calculator. That was the one, and I about wore the thing out. All it has is one little LED readout on it. It's not even LED. It's the, it's the red. It's the old-fashioned red readout on it. It's not even LCD. But you can program stuff into it, assign variables, and do a whole. You can actually write pretty good code on it. So that's what I would do. I would just program stuff like that. So then all we'd have to do is take those variables and trade this expression for them, right? So we'd end up with, well, what I probably want to do here is let me go back and rewrite this. I mean, I'm just going to show you this. Not that you have to do this stuff, but I think it's cool to just see these approaches to solving problems. So we could write this then as equals. That was B, right?
Yeah.
So we just make that A plus B. A plus B times A D plus
BC.
BC minus AB times C plus D, if I just switch the order, all divided by A plus B squared, right? So with that, maybe I don't even have to do this, but you see that that's what I could just do then is type out that expression with A's and B's and C's and D's and hit enter. It's gonna evaluate it for me, because I assigned the correct values to A, B, C, and D. Right? That kind of stuff's pretty handy when you're dealing with really big, and this isn't that big, but in college, you'll deal with things that are, pages long. And then it's way easier to just do stuff like this, right? Okay. All right. But that one's really not too bad, is it? There's some algebra involved, but, it's not that horrible. Okay. What else?
Like 3 minutes.
Got 3 minutes, what can we do in 3 minutes?
Well, I'm just trying to see if there's angle of elevation. Probably if we're going to do anything, I would say maybe
We're gonna have to do one that has like the,
like that one.
The derivative of sine is negative cosine, or is it cosine to negative sine?
it's cosine's negative sign.
Cosine to negative sine.
All the ones with C's have negative derivatives.
Oh,
So let's do 44. I don't know if we can get through the whole thing, but let's see what we can get through for 44.
So all the problems that are on the test today, they're gonna be like types of problems that we've done before though, even on the
Oh, yeah,
assignments or-
Yeah, absolutely. I mean, really, they're all, once you've done a few of these, they're all pretty similar. Okay, so what about this one? Airplane flies an altitude of 5 miles, first point directly over an observer. So we got the 5 in there. That can go in as a constant, right? That's not changing. What other variable would we probably need to look at here?
Speed.
The speed of the plane is 600 miles per hour. Okay, so what variable is going to describe the speed then?
S.
Well, okay, but I could call it x, and really it's just this, isn't it?
Yeah.
Because the airplane is moving
Yeah.
horizontally, right? Everybody see that? So then in terms of what we're given, let's just do this for one of them. Right, what are our snapshot values? Well, we know x is, does it even tell us? Yeah, no, it just tells us x dot, doesn't it?
Yeah.
What is x dot?
Negative 600.
Negative 600 in miles and hours, right? Let's see,
It's negative because it's moving.
it's decreasing.
So
Value of X is
if there was
decreasing.
1,200 miles there.
Got it.
Okay, we're just gonna do part A, so we're told that theta equals 30 degrees, what are we looking for?
Angle of elevation, yeah.
Theta dot.
Right? So we're just gonna set up this is right triangle trig, isn't it? Right, so we've got, we wanna use, what trig function must we use here?
Sine.
No?
Nope.
Cosine, oh, we change it.
How come?
Because you have 5
We don't
miles
have to
per
do
line.
it.
Yeah, because we have no idea what that distance is, right? It's not, we don't wanna calculate it, it's extraneous. So let's just use these two. So we could write this as tangent, but there's even something we could do, darn it. Tangent's opposite over adjacent, that puts the x on the bottom. What might be better?
Cotangent.
Cotangent puts the x on the top. See what I'm saying? They both work.
Works gooder.
Yeah,